today's video, we are going to discuss about the embedded system design process. That is, what is the sum total of the design process happening in every embedded system development as a basic. And also, we'll be discussing various design models. Okay. Actually, this is a very important topic in embedded systems. Okay, so let us see the design process and the various design models. So, in an embedded system, there is actually a life cycle for the development of every embedded system. A particular life cycle or a model is followed. This is that model which is called Embedded Product Development Life Cycle, EDLC. Okay, so this is the EDLC model based on which the every embedded system is getting developed. Okay, or it is getting designed. Here you can see that various stages in this life cycle is there is a need, there is conceptualization, analysis, design, development, and testing happening. That is in the one side. And then there is deployment happening, deployment of the finished product. Then there is support. Then there is upgrade, then retirement. Okay, so what is actually happening here is we are going to first, there will be actually a need of a product initially, which is need. Then there will be conceptualization of that product. That is how the product is going to be like, what will be the various functionalities of the product. Everything we are going to make as a concept, just like a document or something in this conceptualization stage. Then there will be analysis, design, and then the product will be finally developed and deployed. Then if there is any bugs or errors happening, then we'll be doing that, the fixing of that errors in the support phase, and then there will be upgrading of the product. So initially we have made a product. Now we require some changes or some add-ons. So that is upgrade. Then the last thing is retirement, means the products, actually the demand of the product has reduced and it is slowly getting removed from the market. Okay, so this is actually happening in these various phases or various sections of this life cycle. So this design is actually, it is an analysis, design, implementation based on problem solving approach. So here actually we are solving a problem. We are going to find the solution for the requirement of a customer or a client. Okay, based on his requirement or his need, we are actually going to design our product. Okay, so let us see the steps one by one, that is the various stages one by one. So first one is need. Actually I have told you about need. Need means it is the need can come from either an individual or a public or from a company. Need of a product, need of making or designing or manufacturing of a product. That is the first step. Next is conceptualization. Conceptualization means we are going to make a concept, that is we are going to conceptualize these things. That is what is the requirement, what all things need to be done to make the product work in such and such manner. And also we'll be analyzing the performance, cost, everything. And the feasibility study means if you are going for this kind of a machine or a device, then what is the feasibility of the device to work in a proper way. Then risk management, project management, everything we are going to do in this conceptualization. And we'll be making a document out of it most of the case. And that is called the embedded systems concept document. Okay. Next is analysis. Analysis means, so if there is a system, consider that you are going to design an automatic washing machine. Okay. So that is your product. That is your final product. Now, for an automatic washing machine, you know what are the inputs, what are the processes happening in it, and what are the outputs. So here we are going to analyze every aspect of this product, its working and everything based on its inputs and outputs and the interfaces. Okay, so that is done in the analysis phase. Okay, we are going to analyze the product's functioning and everything based on the input, process, output, and interfaces. Okay. Next step is the actual step, which is the designing step. Here we are actually going to design the product. Okay, based on the environment and everything, we are going to create an overall architecture of the product. Next is development and testing. Development, here we are going to actually manufacture the product. That is, we are going to we are going to make the design into a product in the development phase, and also we'll be doing the testing. Then deployment means we are going to place that product in a working environment, or in other words, we can say that we are going to deliver or launch the product, that is a functional product, not a prototype, it's a functional product, to the market. Okay, that is called deployment. Next is support. Support means when this product is being delivered to the actual working environment, there will be some problems, right? There will be some risk factors, there will be some bugs or errors. So we have to do support, means to fix these problems and everything. Okay, so that is done in the support phase. Next, upgrade means, as I have told in the beginning, even though we have made a product, there can be some new versions or new add-ons, like you need this additional functionality, means you have to again upgrade the existing product, right? So that is done in the upgrade phase. Okay, last thing is retirement and disposal, means what happens here is the product has, that is the disposal of the product is happening here. So this product will be slowly discontinued from the market, means its demand has actually reduced, or you can say in a better way that some other better product has come into the market, means this product will slowly get discontinued from the market. That stage is called retirement or disposal. Okay, so these are the various stages in this embedded system development life cycle, that is EDLC. This topic is very important, especially for your semester exams. So when you are going for the semester exams, you don't need to write everything in detail. You just have to draw the diagram and explain every stage in precise words. Okay. Next we are going to see the design models. There are actually a lot of models for embedded system design. We are going to see the most important ones. Okay. First one we are going to discuss is top-down model, and also it can be called as bottom-up design. Okay. So whichever steps we have discussed in the embedded system development life cycle, that is EDLC, all those stages we are including in these models somehow. Okay, somehow everything has to be done, but the way of doing is different for different models. Okay, so let us see the first model, which is top-down model. Here, first step, if you are going for the top-down design means first we will be that just like for the EDLC case, first we'll be listening to the requirements or the needs. Then we are going to make a specification out of it. Then we are going to make an architecture. Then we will decide which all components need to be used on. Then we'll be manufacturing those components, and then system integration. In that, all the components will be integrated together. Okay. So that is called the top-down design. That is, we are going to start from the very basic things, starting from the requirement or the need of the customer to the specification, then making of architecture, then finally forming of components and integrating. Either you can go for that approach, which is called the top-down design, or you can go from the, that is bottom-up. Bottom-up means we have our final product, the concept of our final product we have, and then we'll think which all components we require for forming such a final product. Then we'll design the architecture. That is, if we are going to design the architecture in so and so way, it will form the exact final product. Then we'll go for the specifications, and then we'll finally check whether the requirements are met. Okay, so this is called the bottom-up approach. Okay, so these are the two approaches which can be used for embedded system design. Next one is called the waterfall model. Sorry, it is not waterflow, it is waterfall model. Okay, just like a water is flowing or a waterfall is happening, see here, it is going in this way. So this is actually a unidirectional executional flow. You can see clearly that it is going only in one direction. Okay, just like our EDLC case, all the stages are here. See, all the stages of your EDLC steps are here, but it is going in a straight line, or it is going in a linear form, or in a unidirectional form. Okay, so this is actually a highly structured development or a embedded system design process, or this model is actually a very structured one. Okay, And you can see clearly that output of every stage is being given as an input to the next stage. So first stage is called need. The output of this stage is given to the next stage. See here, conceptualization. And the output of the conceptualization is given to analysis. And also along with every stage, what is the output coming? It is also written. See, for need, there is a statement of need. For conceptualization system, boundary, report. Then analysis, requirements, gathering. Then design, preliminary and detailed design. So just like every phase, for every phase or every stage, there is an output. And the output is marked along with it. Okay, so feedback is available after every stage. Okay, so this is another model, which is a very commonly used type of model also. Now, the main advantage of this going for this model is that it is a highly documented type of a model. Means it is a very structured one and it is having a very perfect documentation. Why? Because the output of every stage is obtaining and we can document these outputs. Okay, so this stages we have already explained while explaining the EDLC. The same steps we are actually following here, but the form of following or the model is different. Okay, so that is the only thing. Now, what is the disadvantage of going for this model is that here consider that you are finding an error in the conceptualization phase. Okay, so first we have analyzed the needs or the requirements, then we have formed a concept, and while forming the concept we have found that there is an error because if we are going for so and so case, there can be an error formed. But even though we have found the possibility of error in the initial stage, we can only correct that in the support phase or after the support phase. Okay, so this is one disadvantage. Even though we have found the possibility of an error in the initial stage, we can only correct it when the support phase or after the support phase is coming. Okay, so that is one disadvantage of going for this model. And here, another important thing is you are getting the feedback from one stage only after that particular stage is being executed. Before that, we are not getting the feedback. Okay, so that is another thing. So this is called the waterfall model. So all the steps we have actually explained: what is need, what is conceptualization, what is analysis, design, then development and testing, deployments, support, upgrade, and retirement. Okay, so all the steps we have discussed, and also along with every step you are getting the corresponding output of that step, either in the documented form or as a data. So the main advantage of going for this waterfall model is that here it is very structured and which is very and also it is very organized and it is unidirectional and it is having a perfect documentation. So whenever you want to have a study of any of the stages, you have a perfect documentation with you. So there is no problem in that. But one disadvantage is that even if there is some errors found or the possibility of an error is found, only we can find it or correct it after the support phase. Okay, so this is the waterfall model. Next one is iterative model. The next model is iterative model. So this iterative model is actually it is similar to that of waterfall model itself. Here the only difference is that you can see that clearly there is a loop formed here, and in this loop there is a cycle-wise steps happening, and this loop will run multiple cycles until all the ambiguities and until all the errors are resolved. This loop or this cycle will run. Okay, so there is multiple cycles happening here within this design, and cycle means this loop will execute. Okay, so while first time when this loop is executing, the main functions or the core functions are identified, and the next time when this loop is executed, the bugs or the errors are getting fixed. Okay, the steps or the stages are same, but the only thing here is there is a iterative process happening here. This is actually the iterative model is actually a modified version of the waterfall model. The only difference in the waterfall model you can clearly see. So this is a waterfall model. So there is no iteration or anything, just a linear process or a unidirectional process or design steps are placed. Okay, But here, if you see, you can see that the steps are placed, but there is a iterative process or a cyclic process happening within the model. Okay, so this cyclic process, thus formation of this iterative or the cyclic stage or this loop is actually formed here in order to correct the errors and identify the working and the main functions correctly. Okay, so if there is some problems, it will be corrected within this loop. Okay, now one main advantage here is that it will be more error free and it will be more better design than waterfall model. And here after every cycle you will get a review. Okay, that is what is happening here, what is the problem, how can we correct it, everything. After that, after the complete set of cycles or loops are getting executed, only then you'll be getting your complete product. So when this loop is executing for the first time or whenever this loop is executing doesn't mean that you are going to get a complete product. Only after the complete set of executions of these loops you will get the complete product. So this is actually one disadvantage. Even though this loop is running multiple times, you are not getting a finished product. You have to actually wait till the last loop or the last cycle to get executed. Okay, so only then you will get a correct error-free product. So this is the iterative model. Next one is a prototype model. So this is actually a loop structure. So here there is actually five stages. So there are four stages. There is requirement definition, prototype development, prototype evaluation, requirements refining. So likewise it will go. Now the advantage of this type of modeling or the prototype modeling here is after the completion of one cycle you will get a finished product. Now if there is further refinement, you will go again starting from the first step, that is requirement definition, then again it will go on all these four cycles. So once this cycle or this loop is getting executed means you will get a finished product. There may be some modifications. If there is some modifications, you will execute this loop next time. So likewise, after the completion or execution of this loop, every time you are getting a product. But in the iterative method or iterative model, there is no such thing. Even though this loop is executing multiple times, there is no guarantee that you are going to get a complete or a finished product. You have to wait until the final cycle or loop to execute. Okay, but in this case, that is in the prototype model, you are going to get a finished product or a partially finished product after every execution. Okay, so that is the case with prototype model. Now this prototype model, what is happening here is first the user or the customer will define the requirement, then the designer will develop the product, and then the designer will evaluate. And if there is some refinements, the customer will suggest, or that is if there is some refining required, the customer will actually suggest the designer or the developer to make so and so corrections. Okay, so again this will execute. Okay, this loop will again further once more execute. So likewise, if there is any refinements that can be added on. Okay, so that is the prototype model. Okay, so when this loop is getting executed multiple times, you are going to get a more and more refined product. Okay, next one is a spiral model, that is the last model. So in the spiral model, there is actually four things actually happening, and these four things will happen multiple times, that is in the loop. Okay, so first one is requirement. So the customer is going to define the requirements, and also okay, sorry. So and also the customer will give you the requirements, the documents for the requirements. Then there will be analysis happening. So analysis of the product will be happening based on the input, processing and the output. Then there will be designing, that is formation of the requirements to a representation form, that is happening in the design phase. Then there will be implementation. Okay, and this thing will happen multiple times. So this is like a loop structure, which is a spiral model. Okay, so this is all about the various design models which are formed or used for embedded system design. So I'm really hoping that you found the video useful. So in this video, we have actually discussed regarding the embedded system development or the design stages, that is EDLC, the life cycle, various steps, and also we have seen various models. Okay, so I've tried to include all the important models in this video. So I'm really hoping that you found the video useful. If yes, please do give it a thumbs up. Also share it with your friends. And if you want more videos, please do subscribe to the channel. If you want to download the PPTs of this lectures, that is every time I'm uploading a lecture on embedded system, if you want to download the PPTs of that lecture, that will be available in our Telegram channel. Okay, so please do subscribe to that also. And also follow on Instagram for getting the updates regarding the jobs and everything. Okay. So that's it. Please to subscribe. Thanks for watching and keep on watching.